everybody, welcome back. In this session, we'll discuss worksheet questions based on thermodynamics. We'll see which of the following statement is not true. Observe the strings carefully. Not true. Specific heat capacity is dependent on nature of the substance. It's a correct statement. And specific heat capacity depends on temperature. Specific heat capacity depends on temperature. Yes, as specific heat in a range of definite range of temperature, it will possess a constant value. Afterwards, it will change. And specific heat capacity of water does not vary with temperature. No, this if you are accepting B, then even C also should be accepted. That's why we are taking definition of one standard calorie, that is water's requirement of heat from 14.5 degrees Celsius to 15.5 degrees Celsius. Right, that means it varies. So we defined a specific boundary for it. So it's a wrong statement. It is a wrong statement actually. And SI unit of specific heat capacity is joule per kg Kelvin. Yes, this is correct only. So he is asking not true. Obviously C option. Next, find the difference in temperature between the water at the top and the bottom. Height h is equal to 20 meter. Waterfall, assuming 10% of energy of fall is spent on in heating the water, only 10%, efficiency 10%. Okay, use specific heat capacity of water 4000 only, not 4200. He is asking. Law of conservation of energy. mgh into efficiency is equal to half mv square, of course converted into mc delta theta. So m gets cancelled. GH into eta is equal to C delta theta. So GH into eta by C is equal to delta theta. Implies what is GH? G value 10, H value H 20, and eta value 10 by 100, 10 by 100 into C value 4000 to 4000. Okay, is equal to delta theta. So 1, 2, 3 zeros, 1, 2, 3 zeros will go. So it is 1 by 200. 1 by 200 means 0.005. This is delta theta. So yes, answer is correct. Yes. When a gas expands adiabatically, its volume is doubled. V2 is equal to 2V1 and it's an adiabatic thing. Next. While its absolute temperature is decreased by a factor of 2, T2 is equal to T1 by 2. The value of adiabatic constant, that means gamma equal to how much? Okay. So what is the relation between TV? Relation between TV? Yes, you are right. TV relation is TV power gamma minus 1 is equal to constant. That means T1 V1 to the power of gamma minus 1 equal to T2 V2 to the power of gamma minus 1, T1 by T2, T1 by T2 is equal to V2 by V1 whole power gamma minus 1. T1 by T2 is 2, V2 by V1 is 2 power gamma minus 1. This is power 1 only. So whenever bases are equal, powers can be equated. Gamma minus 1 is equal to 1, gamma equal to 2. You got 2. That means option C. Next, assertion and reasoning. Heat and work are modes of energy transfer to a system resulting in change in internal energy. Reason: heat and work in thermodynamics are state variables. The correct option among the following is, the options are A is true, R is also true and the correct explanation, and blah blah blah, and last one is A is false and R is true. So we need to select. Yeah, heat and work in thermodynamics are state variables. No, state variables are P, V, T, right? So reason is not true, but assertion is okay. Assertion is correct. So option will be C in this. Yeah, option will be C. Yes. Next, a metal pot having a base area A is equal to 0.2 meter square and the thickness T is equal to 2.0 centimeter, conversion 10 power minus 2, and it boils water at a rate D q by dt is equal to 3 kg per minute. Kg per minute means I need to change, that is not dq by dt, dm by dt. So unit sometimes will help us. Placed in the hot pot. The temperature of the part of the pot plate in contact with the pot is approximately, okay, temperature part of the plot. Then thermal conductivity of the metal is, thermal conductivity is equal to 120 joule per second meter per Kelvin. Heat of vaporization of water is equal to heat of vaporization of water, H is equal to, I can write 2 into 10 to the power of 6 joule per kg. Joule per kg, it's nothing but latent heat of vaporization, right? So anyway, no problem. So how to do, which formula can be used? It's a multi-formula based question, right? Yes. So those multi-formulae are, you see, rate of heat transfer is equal to Ka delta theta by L is equal to ml by T, which is nothing but rate of heat transfer dq by dt. Okay, this task we need to use. Yes. So of course this is L only. Next, K value 120, area value 0.2, temperature difference we need to find that only with the pot approximately. Okay, so temperature difference only we have to find out, delta T, delta theta, whatever, by L. Length is nothing but thickness, 2 into 10 to the power of minus 2 is equal to m by t is 3 kg per minute, by 60 you have to take, and L value 2 into 10 to the power of 6. From this the temperature will come as, temperature roughly it's 162, yeah, 183, it's very close. So temperature you can find it up. So theta is equal to 183 degrees Celsius. Next, consider a reversible engine of efficiency eta is equal to 1 by 6. When the temperature of the sink is reduced by 82 degrees Celsius, its efficiency gets doubled. Sink temperature T2 usually. If it is T2 dash, that means T2 minus 82, change in degrees, change in Kelvin will be same only. Then efficiency became doubled. Double means eta dash is equal to 2 times of 1 by 6. That is nothing but 1 by 3. Whenever T dash is equal to this one. The temperature of the source and sink respectively. Okay. First one we can write like this. Eta equal to 1 minus T2 by T1 is equal to 1 by 6. So we can write it as T2 by T1 is equal to 1 minus 1 by 6, that is equal to 5 by 6. So T2 by T1 5 by 6. Here also we will apply 1 minus T2 dash by T1 dash is equal to 1 by 3. That means T2 dash by T1 dash is equal to 1 minus 1 by 3 is 2 by 3 is 2 by 3. Next, what is T2 dash? T2 dash equal to T2 minus 82. T2 minus 82 by, what is T1 dash? T1 dash is equal to 2 by 3. These are the things we got. These are the things we got. So here we can write T2 is equal to 5 by 6 T1, or T2 equal to 5 by 6 T1 on, and T1 is not changed, only T2 is changed. So I can substitute the same value here. T1 is T1 only. Now we can go like this. T2 minus 82 by T1. T1 is equal to 6 by 5 T2. T1 is equal to 6 by 5 T2. 6 by 5 T2 is equal to 2 by 3. Okay. Now cross multiplication. T2 minus 82 is equal to 2 by 3 into 6 by 5 T2. So 3 will go 2 times. So 2 2s are 4 by 5. 4 by 5 minus 4 by 5 is equal to 82. So 4 by 5 T2. So 5 T2, 4 T2, T2 by 5. T2 by 5, that is 82 into 5. How much? 5 2s are 10, 1 5 8s are 40, 41, 410 Kelvin. It will give you in Kelvin, 410 Kelvin, not in degrees Celsius. So 410 by 273 is equal to 7, and 10 minus is 3, and 1 will go, it is 137 or 37. 410 only correct, yeah. If it is 37, then option D will come. So option A, that means 310 should come, T2 310, not 210. 41, 410 only. 410, but he gave 310. Okay, let me verify and we will continue. And we have T1 is equal to 6 by 5 T2. 6 by 5 T2 means 6 by 5 into T2 is 410. So it is going to become 82. 6 into 82. 6 2s are 12. 1 492. 492. So option A is correct only. I just changed it. Next. If you at all any what you call correction in the calculation, you just do, but this is the procedure. Okay. Next. Diatomic gas Cp is equal to 7R by 2, that everybody knows. Does 200 joule of work. dW is equal to 200 joules. It's expanded isobarically. Okay. The heat given to the gas in the process is equal to dQ is equal to how much? Isobaric process, work done formula. Yes, these are the formula. We have dQ equal to NCP dt, and dW is equal to dQ minus du. That is nothing but NCP dt minus NCV dt. From this I have a technique, that is dQ or dW by dQ will be NCP dt minus NCV dt by NCP dt. So it will be 1 minus CV by CP. CV by CP is 1 by gamma, that is dW by dQ. Now dW is 200, dQ is we have to find, and 1 minus 1 by gamma is 7 by 5. So it will be 1 minus 5 by 7. This will be 2 by 7 is 200 by dQ. Cross multiplication dQ equal to 700. So in an office room contains about 2000 moles of air. An office room contains about 2000 moles of air. N is equal to 2000 moles. The change in internal energy delta U is equal to of this much internal energy of this much air when it is cooled from delta T or delta theta equal to 24 34. Delta 34 to 24 is 10 degrees Celsius. At constant pressure is equal to 1 atmosphere, maybe 1 atmosphere. Is dash. Internal energy he is asking. Internal energy du is equal to half NF r dt. So directly we can use half. Which type of gas it is? Is it monoatomic? Gamma value is given 1.4. Gamma value 1.4 means which type of gas that is? Gamma value we have 4 by 3, gamma value 7 by 5, gamma value 5 by 3. Gamma value 5 by 3. We have 3 types. What is this? 1.66. And what is this? 1.24, 1.4. And this is 1.33. So this is which one? Polyatomic. This is which one? Diatomic. This is which one? Monoatomic. So here it is diatomic gas he indirectly gave. So N is equal to 2000, and degree of freedom for diatomic gas is 5 and delta theta 10. So this 2 will go 1000. So 5 into 10 to the power of 4. 5 into 10 to the power of 4, and R I didn't multiply. R is equal to 8.3 into 8.3 also there. So 40 into 10 to the power of 4, of course some number will come, 42 maybe, 42. Then yes, is cooled, so obviously negative, cooled, right? That's why 10 power 5 number came 4.2 3 zeros 4 zeros. Okay, 4.2, then it's not 42, it should be 4.2. 4.2, then automatically 5 will come. 4.2 into 10 to the power of 5 with a negative sign. This is 4.2, not 42. 4.2. Yeah, next. An ideal Carnot's engine whose efficiency is equal to 50%. 50%, that is equal to 1 minus T2 by T1 is equal to 50%, 50 by 100. 50 by 100 is 1 by 2. That means T2 by T1 is equal to 1 minus 1 by 2. 1 minus 1 by 2 is 1 by 2. That means T2 is equal to T1 by 2. This much of conclusion from the first one. This is heat at 500 Kelvin. That means T1 500 Kelvin. He gave T1 is 500 Kelvin. If the efficiency is to be 60%, the intake temperature for the same exhaust temperature is, intake must be how much? Intake, exhaust is same, 60% efficiency. 60% efficiency, if you want, 1 minus T2 by T1 should be changed, he is talking. T2 is same only, he is. So T2 here, what I can get? T2 implies T2 is equal to 500 by 2. 500 by 2 is 250. That 250 I will use here. So 6 by 10 is equal to 1 minus T2 is 250 by T1 dash. So 250 by T1 dash is equal to 1 minus 6 by 10, that is equal to 4 by 10, that is equal to 2 by 5. And T1 dash is equal to cross multiplication, 250 into 5 by 2, that is 125. 125 into 5, 125 plus 500, 625. Yes, B option, 625 Kelvin. I'm also doing freshly. Okay, I don't know the solutions of all these. I'm also doing along with you. So we both doing together. Next, consider two-stage Carnot engine. In the first stage, Q1 is absorbed at temperature T and Q2 is expelled at temperature maybe alpha T. Okay. In the second stage, Q2 is absorbed, okay, at alpha T and Q3 is expelled to beta T. Efficiency of the Carnot's engine will be, excellent. This is T1, first T only. And the next one is alpha T, and it is taking heat here, and it is beta T. Okay, the efficiency of the Carnot's engine is two stages. Q1 is taken here and rejected Q2 again, and the second stage Q2 is taken here and Q3. Okay, then efficiency is equal to, you have to write the formula for two stages and you need to couple them. Here it is taking Q1, rejecting Q2. So work done in this process, W1 is equal to Q1 minus Q2. And here it is taking Q2 and rejecting Q3. So work done is Q2 minus Q3. So efficiency is equal to W1 plus W2 by heat taken is Q1. So this is Q1 minus Q2 plus Q2 minus Q3 by Q1. That is nothing but Q1 minus Q3 by Q1, which is nothing but 1 minus Q3 by Q1, which is nothing but 1 minus T3 by T1, implies efficiency eta equal to 1 minus T3. T3 is beta T by T1. T1 is T. So that is 1 minus beta. eta equal to this is actually T1 is equal to T, T2 is equal to alpha T, and T3 is equal to beta T. Wherever T3, that you can substitute. So it is 1 minus beta, option C. Next, an ideal gas at temperature T, pressure P, occupies a volume V. If its temperature is halved and pressure doubled, what is its new volume? If its temperature is halved, pressure is doubled. Let me write. If its temperature T2 is equal to T by 2, right? Yeah, temperature is halved, pressure is doubled, and what is new volume? V2 is equal to how much? An ideal gas occupies, okay, using ideal gas equation. Ideal gas equation. What is ideal gas equation? P1 V1 by T1 is equal to P2 V2 by T2. P1 P, V1 V, T1 T, P2 T by 2, V2 don't know, T2 oi, P2 is 9, yeah, what is that? P2 is 2P, T2 is T by 2, T by 2 I'll take here. So TT cancel, PP cancel, and here V is equal to, here 4V2, that means V2 is equal to V by 4. Option A, yo, yes, encourage yourself. Next, a diatomic gas, gamma is equal to 1.4, does 300 joule of work, dW is equal to 300 joule of work. When it is expanded isobarically, the heat given to the gas in this process is dQ equal to how much? You know, dW by dQ is equal to 1 minus 1 by gamma. So dW 300 by dQ is equal to 1 minus 1 by gamma, 1 by 7 by 5. So this is 2 by 7. So 300 into 7 by 2 is equal to dQ. So dQ equal to 157 or 15 sevens, I don't know, 15 table need to be multiplied. 1050. J option, first option, yeah, 1050 joule. Next, graph. PV diagram indicates paths along the sample can be taken from A to state B, A to B. The energy equal to 5 PV. Energy equal to 5 PV. Energy equal to 5 PV. In the form of heat, the energy equal to 5 PV in the form of heat, it is required to be transferred. dQ is equal to 5 PV. Okay, if the path 1 is chosen, this is path 1 is chosen. Path 1 A to B. How much energy in the form of heat should be transferred in the path 2? So dQ equal to question mark if it is path 2. So that is the thing. Final stage is same, but initial stages are different. Initial stage, first one is PV, second one is 3 by 2P comma V. So from this we need to discuss. Actually this question is missing one simple condition, that is temperature same for initial, T same for the two processes, initial temperature, T not same for the two, that he need to give. So if and only if that, then only we can do this type of sum. Anyway, the work done in the first process is dW equal to, in the first process A to B, work done is equal to P delta V. P is P, delta V is 3V minus V, that is equal to 2PV. 2PV is the work done. Then implies first law of thermodynamics causes du is equal to dQ minus dW. dQ is 5PV minus 2PV, which is equal to 3PV. 3PV is internal energy 3PV. So A to B, what is internal energy change? 3PV. So that we can use in the second process. In the second process, what is the work done? In the second process, the work done is, equal to this work done 2PV plus the triangle area. Triangle area is half into base is 2v into height is 3 by 2p minus p, 1 by 2p, 1 by 2p. So 2 will go, it is pv by 2, pv by 2, 2 2s are 4 plus 1, 5 by 2 pv then. This is dw. Now du is equal, du same only. Now what you want? dq equal to du plus dw. dq is 3 pv and dw is dw 5 by 2 pv, 5 by 2 pv. That is 3 2 3s are 6, 11 pv. Carnot engine with efficiency, it operates between two heat reservoirs T1 and T2, T1 greater than T2. T1 is, if T1 is changed by 0.4%, the change in efficiency delta eta 1. If T2 is changed by 0.2%, efficiency is changed by delta eta 2, then delta eta 1 by delta eta 2 is equal to, okay, 0.4% and 0.2%, 0.4% and 0.2%. Separately for delta eta and delta eta 2 must be done and should be divided. In errors and approximation, we have this technique. You see, eta is equal to 1 minus T2 by T1. If change in fractional change, that is change in eta by eta, fractional change is equal to differentiation, nothing but change in T2 by T2 plus change in T1 by T1, fractional changes. So let us use this formula for the two cases so that we can do it simply, not to make it so much big. So delta eta by eta, first case is eta 1, okay, this is 1, I can call it as 1, is equal to, in the first case, which one is changed? T1 is changed but not T2, so this will be 0, change is 0, plus T1 is changed by 0.4%. see, T1 is changed by, T1 is equal to 0.4% of 4% change in, delta T1 equal to 0.4 by 100. So delta T1 can be replaced with 0.4% of T. So delta T1 by T is 0.4 by 100. 0.4 by 100, and delta eta by eta 2 is equal to, this is 2 only changed, so that means 0.2 by 100 plus 0. Now dividing one with other, delta eta 1 by delta eta 2 is equal to, this will be 0.4 by this will be 0.2, so 100 will go now, so this is 4 by 2, that is 2 only, that is 2 only, yes. Here he said increased or decreased, whereas if T2 is changed, whereas T1 is changed, because plus and minuses are also there. Here I took only plus symbols. Denominator 1 is changed, so for T2 you need to put minus sign, then obviously this minus sign will come. So if you put for T2 minus sign, then you will get minus sign. So minus 2% will come. Next, 1 mole of nitrogen gas being initially at a temperature T0 is equal to 300 Kelvin. 1 mole, N is equal to 1 mole being initially at a temperature T0 is equal to 300 Kelvin. T0 is equal to 300 Kelvin. Adiabatically compressed to increase its pressure adiabatically. Its pressure P2 is equal to 10 times of P1 adiabatic. Final gas temperature after compression is, final gas temperature after compression is, final gas temperature after compression. Oh, T2 he is asking, okay, T2 is asking, this is T1. Okay, again nitrogen gas molecules, gamma is equal to diatomic, rigid diatomic, and 100 to the power of 1 by 7 is 1.9 you need to use. Gamma value 7 by 5 or a fraction you can use, 7 by 5, okay, fine. Now TP relation, TP relation for adiabatic process is P power 1 minus gamma, P power 1 minus gamma, T power gamma equal to constant. So I can write 1 1 is equal to P2 to the power of 1 minus gamma and T2 to the power of gamma. So we can write P1 by P2 whole to the power of 1 minus gamma by gamma is equal to T2 by T1. Direct steps. So T2 we want. Yeah. T2 is equal to T1 of this 1 minus gamma by gamma. What is here P1 by P2? P1 by P2. P1 by P2 1 by 10. Na? Correct? Huh? P1 by P2 is 1 by 10. Yes. Now T2 is equal to T1 300 Kelvin into 1 by 10 whole to the power of 7 by 5. 1 minus 7 by 5 by 7 by 5. Why like this? 1 by gamma minus 1 we can take. 1 by gamma minus 1 we can take. Gamma is 5 by 7, right? 5 by 7 minus 1, that is 2 by 7. 2 by 7 means we'll take like this, 300 into 100 to the power of minus 1, okay, power 1 by 7 will be as usual, that is 1.9. So 300 by 1.9 will come because power minus sign is there. So final temperature after the compression is equal to 300 by 1.9. 300 by 1.9 is, yeah, here this 7 minus 2 by 7, so this is minus sign, minus minus will go, so this 1.9 will become into 1.9 will become into 1.9, 1.9 to roughly 600, roughly 600 means 570 I can take, 570 Kelvin, option D. Yes, next. Temperature of cold reservoir T2 is equal to 127 degrees Celsius. Never do sum in Celsius. Plus 273 you need to add. So it is 200, 200, 400. If the efficiency of the Carnot heat engine is equal to 20%. And then temperature of hot reservoir is equal to 1 minus T2 by T1. So T2 by T1 is equal to, T2 by T1 equal to 1 minus 2 by 10. 1 minus 2 by 10 is 8 by 10. So T1 is equal to T2 into 10 by 8. T2 value 400 into 10 by 8. 500 Kelvin. There is degrees Celsius. First option is a basket. Minus 273. So it will go 7 times and it will be 9 minus 2. So it is 4, 227. 227 is the B option. Don't put first option, take care. A gas in a closed container undergoes a cycle ABCA is shown in the figure. The net heat released by the gas after it has undergoes 2 cycles is net heat released after 2 cycles. Okay. After 2 cycles is, if you observe closely the diagram, it's a anti-clockwise process. That means negative work done. That means heat will be what you call not absorbed, released. You can feel like that. So what is the area enclosed by the graph? Area enclosed by the graph is half into base 5 to 20. 5 to 20. 20 minus 5. Into height is 30 to 10, that is 20. Yeah, 30 to 10 is 20. Yeah, this is area. So this area will be 15 tens are 150. Correct? Check it up the units, meter cube and everything. Okay, this is 20, 15 tens are 150. Yeah, so 2 times of area will be 150 into 2. 150 into 2 will be 300. And all the units, this is pressure correct only, this is meter cube correct only. How many moles the net heat a closed container contains? Number of moles, it may not be 2 cycles, it can be 20 cycles. If it is 20 cycles, 20 cycles, then obviously you need to multiply with 20. Then you can have 3000 joule. That means 3 kilojoule. So it is 20 cycles, not 2 cycles. A gas does 4.5 joule of external work. 4.5 joule of external work during adiabatic expansion. Okay, gamma. And if its temperature falls by 2 Kelvin, delta T is equal to 2 Kelvin. Its internal energy change. Okay, F value, the gas name also he didn't mention. Okay, so change in internal energy is equal to half NFR dt, right? So half N value, number of moles, work done is given. From that you have to bring it up, right? Or you can go for heat supplied. So all those things you need to do. Not like this. Have to use work done, right? Yeah. Why am I doing this much for a small question? Let us think in a different way. Wait. Why should we think a lot? It's a simple thing. See, we have dq is equal to du plus dw. Okay, dq is equal to misleaded by temperature change. dq is 0 because it's adiabatic process. Then du is equal to dw is 4.5. Then du is equal to minus 4.5 joule. That means internal energy decreases by 4.5 joule. So option B. So simple. Carnot's engine operates between a source and sink. The efficiency of the engine is 40% and the temperature of the sink is 27. Temperature of the sink is 27 degrees Celsius, nothing but 300 Kelvin. And efficiency is 40%. 40 by 100 is equal to 1 minus T2 by T1. I can write first. So T2 by T1 is equal to 1 minus 4 by 10. 1 minus 4 by 10 is 6 by 10. And now T2 equal to 300. T1 is equal to, this is 3, 2, 3, 5. So 5 T2 by 3. T2 is 300. So 500 it will come. Kelvin. So first data is this one. If the efficiency is to be 50%, then the temperature of the source must be increased by, efficiency is equal to 50%, that is equal to 1 by 2, that is equal to 1 minus T2 by T1 dash, because T2 is same only, T1 dash. So T2 by T1 dash is equal to 1 minus 1 by 2 is 1 by 2. So T1 dash is equal to 2T2. T1 dash is equal to T2. What is T2 here? T2 already given 300 Kelvin. That only we can put. So 2 into 300 Kelvin. That is 600 Kelvin. T1 dash 600 Kelvin. But T1 500 Kelvin. So it must be changed by, change of T1 is equal to 100 Kelvin. Isn't it? Yes. 5 gram of steam at 100 degrees centigrade is mixed with 5 gram of ice at 0 degrees Celsius. The final temperature of the mixture is, 5 gram of ice at 0 degrees Celsius needs how much of heat for melting? Heat required for melting is equal to ml. ml is equal to 5 into L value 80. 5 8s are 40. So 400 calorie only. Even 1 gram of steam on condensation only gives 540. So obviously final temperature will be at 100 degrees Celsius only. So final temperature is 100 degrees because 1 gram itself will give you 540 calories. So still is lesser. So obviously entire ice whatever molten will come to 100 degrees Celsius. 3 Carnot cycles operates between the temperatures T1 and heat sink T4. So T1, T2, T3, T4, 3 engines. There are 2 other reservoirs at temperatures T2 and T3. Okay. The 3 engines are equally efficient. If the 3 engines are equally efficient, then he is asking relation between 1, 2, 2, 1, 4, 2, 3, 1, 4, like that, blah, 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 blah. Equally efficient. Eta 1 is equal to eta 2 is equal to eta 3. This is 1 minus T2 by T1, that is equal to 1 minus T3 by T2. that is equal to 1 minus T4 by T3. Suppose if you take only 2, then what will come? 1 minus 1 minus 1 will go. So T2 square is equal to T1 T3 will come. If these two are taken, what will come? T3 square is equal to T2 T4 will come. Okay, that only. So T2 square is 1 and 3. T2 square is 1 and 3. T2 square is 1 and 3. Everywhere 1 and 4 only are there. And powers are also different powers. So we can manipulate this. T2 square is equal to T1. T3 can be written as root over T2 T4. So T2 square minus 1 by 2 is equal to T1 into T4 to the power of 1 by 2. So that is T2 to the power of 3 by 2. 3 by 2 is equal to T1 T4 to the power of 1 by 2. So T1 is equal to T2 to the power of, power minuses are not there. Okay. So T2 to the power of 3 by 2 and T4 to the power of minus 1 by 2. So similarly you can get T2, similarly T3 and T4, so that you can check which option will be better suitable. So after simplification you can get a better option C. Isothermal process is the graph between isothermal process, pressure and temperature, pressure and volume, volume and temperature. See, isothermal, it will give you a straight line, PV and temperature, it also will give you a straight line only. Pressure and volume will be parabolic graph will come. So option B. Next, a system is taken from state A to B along two different paths. The heat absorbed and work done by the system along these two paths is Q1, Q2 and W1. Then W2 respectively. So internal energy should be same, right? So Q1 is the heat given, then W1 and du will be there. And in the second case Q2 is there, W2 and du will be same only, no? Here I can write Q1 minus W1. So W2 is equal to Q2 minus Q1 plus W1. So which option is this? W2 is equal to Q2 plus W1. Q2 plus W1. I can write like this: du is equal to Q1 minus W1 or du equal to Q2 minus W2. So internal energies must be same, right? Internal energy change. So in that aspect, if I speak, then this one, the C option is somewhat closer, but one error is there. If it is Q2, then it will be, yeah, it is Q2 actually. Next, the relation between efficiency of a heat engine and the quotient of performance alpha of a refrigerator is, relation between that and this. See, alpha is equal to amount of heat rejected, that means the amount of heat pulled out from the sink by work done. So that is equal to Q2 by Q1 minus Q2. That is nothing but T2 by T1 minus T2. But eta is equal to 1 minus T2 by T1. This is nothing. This is nothing but here 1 by alpha is equal to T1 minus T2 by T2. That is equal to T1 by T2 minus 1. Yeah. So 1 by alpha is equal to, this is 1 by alpha equal to T2 by T1 is equal to T2 by T1 is equal to 1 minus eta, right? So 1 by 1 minus eta, this must be 1 by 1 minus eta, minus 1. So it's going to become 1 minus 1 plus eta by 1 minus eta. So 1 by alpha equal to eta by 1 minus eta. So whatever is most suitable, that you can take up. And This is eta subjected. This is not alpha subjected, eta subjected. Okay, no problem. So alpha is equal to 1 minus eta by eta, that is equal to 1 by eta minus 1. So alpha plus 1 is equal to 1 by eta, eta is equal to 1 by 1 plus alpha. 1 by 1 plus alpha. Plus and minus 1 by 1 plus alpha. Yes, B. Next, there is no change in internal energy if an ideal gas, when it undergoes change in internal energy, temperature must be kept constant. That means what you call isothermal, adiabatic, isobaric, and free expansion. Free expansion. Free expansion. That means work done will be 0, heat absorption rejections will be 0, and whatever we are going to discuss. So if we consider isothermal process, other parameters may change, but in vacuum expansion, you can expect this thing, right? That's why. So most probable answer is free expansion. Isothermal process also, internal energy need not be constant, only temperature point of view. Okay, what about NFR? Remaining things are there. And when 50 gram of water at 10 degrees Celsius is mixed with 50 gram of water at 100 degrees Celsius, the resultant temperature is equal to M1 C1 theta 1 plus M2 C2 theta 2 by M1 C1 plus M2 C2. M1 C1 50 into C value 1 into 10 plus 50 into 1 into 100 by 50 into 1 by plus another also 50. Yeah, okay, another also 50. Hey, then why don't we go for average simply? 100 plus 10 is both are equal. No, I didn't check. 155 will come. 50 into the 1. Yeah, so this will be 50 on taking common, this will be 110. Yes, why this is 250s? Yeah, why don't you go for average? Whenever equal amounts of same substance are merged, then happily you can go for averaging. So read the question with attention, then you can do sums fastly, matching the following. Okay, options. So read carefully. T1 is given, T2 is given, list 2. Carnot heat engine, list 1 corresponding to efficiencies. Okay, efficiency is equal to 1 minus T2 by T1. Only consuming question, time consuming, that's it. So you can substitute every option and you can check. One, if you want, I can do. Eta for the first one is equal to 1 minus A. First option A is matched with 3, 3, 3. Why should I do this one? This is second one. B I will do. B. 1 minus T2 350 by 500. So 0, 0 will go. 5 table 7 by 10. 7 by 10 means 3 by 10. 3 by 10 means 0.3. That means 2. Yes. 0.3. That means second option. So B should be measured with second option. So it's D. Yeah, like that use. Fastly you can do. A gas expands with temperature according to the equation V is equal to K T to the power of 2 by 3. So where K is a constant. Work done when the temperature changes by delta T is equal to 60 Kelvin. What is the work done? We'll try like this. PdV is the work done. That is equal to P can be RT by V. For 1 mole of gas, we will try RT by V into dV. So work done is equal to RT by V is equal to KT to the power of 2 by 3 dV. R into T is T only and 1 minus 2 by 3 by constant into dV. That is equal to R by K into T to the power of 1 by 3. What about dV? dV also must be converted into, you can take this one only. dV is equal to 2 by 3 K T to the power of minus 1, so 1 by 3. So dV can be 2 by 3 K T to the power of 1 by 3. So what we got, kk will go, 2 by 3 will be left, and into dt will be there. So that dt will come. So t to the power of a power m, a power, this one also same, both are same we got. 3 ones are 3. So here minus 1. So it is minus 1 by 3. Yeah. Minus 1. So minus 1 by 3. This is minus 1 by 3. T power 0 into dt will come. This is equal to dw. dw. Yes. So on integration, integral of dw is equal to w is equal to integral of this is r is there. So 2r by 3 dt. 2r by 3 dt is 2 by 3 rt. And temperature is changed by 0 to 60 I can. So 60 Kelvin I can put. So 60 R into 2 by 3 is there. So 3 will go 20 times. 22s are 40 R. Next, thermally insulated vessel with nitrogen gas at T1 is equal to 27 degrees Celsius. Convert it into Kelvin, and then moving with velocity v is equal to 100 meters per second. The vessel is stopped suddenly, then the percentage change in pressure of the gas is nearly, if you stop the vehicle, work is done on the gas, then what happens to the pressure? So this is, we can do like this. Whatever the kinetic energy, n into half mv square, moving with velocity, and if the vessel is stopped suddenly, okay, is converted into internal energy, half nfrt, dt I can write. That only we are going to change, isn't it? What is that? Then the percentage change in pressure we have to, okay, dt is there, half nfr dt, okay. And we have one more, pv is equal to nRT. Here volume of the vessel not changing, so pressure will change. So dp into v is equal to nr dt. So nr dt here also there. So I would like to divide with p, because he is asking percentage change in pressure. So dp by p is equal to, dp is nr dt by v into p is equal to nRT by p, v. So nRT, nr will go, vv will go, so it is just dt by t, yeah, dt by t. So t is dp by initial temperature is already given. Very good, final, very good. So the dt is equal to nn will go anyway, half mv square by dt I'm establishing, half nfr, so dt I got, into t. So this you can substitute, half will go, nn will go, just it is mv square by frt. Degree of freedom, which type of gas it is? Assume that the nitrogen gas, N2 molecule, diatomic molecule. So gamma or F is equal to 5 you can, and nitrogen molecule, nitrogen N2, each one is 14, 28 will come M, and velocity is given, okay, fine. So everything you can substitute, R value 8.2, then 28 into 100 by F is 5 into R value 8.2 into Kelvin 300. So it gives to almost 2.25, right? Yeah, 100 this will go, so 2.25. Absolute temperature, we have eta naught is equal to 1 minus T2 by T1. Okay, and eta is equal to nu 1 is 80% increased, that means 180 by 100 of eta naught. This is nothing but 9 by 5 eta naught is eta, we'll put aside. And also eta is equal to 1 minus T2 by 25% is increased, 125 T1 by 100. So it is eta is equal to 1 minus, this is 4 T2 by 5 T1. Okay, and suppose here onwards eta naught can be written as 5 by 9 eta is equal to 1 minus T2 by T1, and implies T2 by T1 is equal to 1 minus 5 by 9 eta. Why can't we substitute that here? So eta is equal to 1 minus 4 by 5 into 1 minus 5 by 9 eta. So it will be 1 minus 4 by 5 minus of minus plus 4 by 5 into 5 by 4 5 by 9 eta. 5 gets cancelled. So this is eta. So 4 by 9. Okay, eta minus 4 by 9 eta is equal to 1 by 5. This term came this side. 9 ones are 5 by, this is 5 by 9 eta is equal to 1 by 5. So eta is equal to 9 will come this way, 9 by 25. So eta you want in percentage, then into 100. Into 100 will go 4 times, 4 9s are 36%. In percentage, 9 by 25 into 100, that is equal to 36%. So option D. Yes. Keep on practicing. We'll discuss other chapter in the next session. Bye.